Hi, everyone. Welcome. I'm Dave Gruber, a principal analyst with the Enterprise Strategy Group, now part of Omdia. Today, we'll be diving into an extremely timely and relevant topic, talking about the security data layer. More specifically, exploring the use of data fabrics in support of an increasingly diverse operating environment that we face today in the AI era. Joining me for this discussion is Robin Daz, Executive Director and Growth Strategist for DataBee, a Comcast company. Please say hello to our audience, Robin.
Well, hello, audience. How you all doing?
Thanks. So as the AI era drives transformation across virtually every aspect of the technology-driven enterprise, security strategies have to transform too. And as security leaders take on this category of AI-driven risk, existing security strategies must rapidly evolve with it. But more than evolution, net new AI threat vectors have emerged, and they require new investments in people, understanding, right, of these environments, the processes within our security teams to secure them, and the technology that underlies much of it. Meanwhile, new levels of scale and flexibility are being required, pushing the existing infrastructure to its limits, causing many to re-architect some of the foundational capabilities in support of the new AI-powered world. Well, at the core of this conversation is the security tech stack and the security data layer that fuels all of the intelligence into that stack. This has been challenged already to handle the scale of signals from an increasingly diverse and complex set of security controls and so many tools that people use. And in response, SIEMs has been under fire for some time now, although SIEM has somewhat reinvented itself over the last couple of years. And with many investing in XDR tools as a potential solution to refine some of the lack of capabilities that prior SIEMs had. But the AI era is really forcing us to even take a bigger look as more exponential levels of security data growth are occurring. And certainly much more data to come with the addition of agentic AI solutions. So for many organizations, this means the security data layer will quickly reach the limits of its capacity or capabilities as people have them implemented today, causing many security architects to reconsider current strategies and look for new approaches. In the conversation, we'll be chatting about data lakes, next-gen SIEM, data pipeline management solutions, and importantly, data fabrics, which is what we're going to explore today with help from Robin. So let's get right to that. Robin, let's start off with an introduction of what is a data fabric. How is it different from traditional security data strategies or just generally data strategies? And how does it apply to more specifically cybersecurity data? And what are some of the benefits that are associated with that? So paint us a picture.
well, yes, I'll do my best because there's a lot to unpack there. I mean, I think sort of first off, maybe if we sort of jump into sort of what a data fabric is. I mean, I think it's been something that's been used in other industries, and I think finally is sort of approaching security. I really think of it as being a bit of a decoupling between sort of a couple of different dimensions, decoupling between sort of the data between proprietary formats, and so it's removing the data from where it has a gravity, and where it has gravity is in the tools that it's produced. So that's step number one, and then it's kind of extracting that out and kind of creating this sort of many-to-many approach. And so instead of it being sort of stuck in a place and having to feed all the applications, and something else being stuck in a place and having to feed all the applications, and all the applications are sort of crossed, a lot of sort of cross wires. Like, I think the essence of a data fabric sort of extracts, or at least one approach is it extracts the data from where it is, and it cleans it up and it puts it into a normalized format, like a standardized schema, and then from this sort of pool of truth, the single source of truth, that's where you can then feed all the applications that are required by it, versus application A pulling out a tool B and tool C feeding application A, B, and C. It tries to simplify that sort of journey for dating. So I think if nothing else, if you think about sort of a security data fabric, think sort of a decoupling and a more flexible approach to your data.
But can I ask? If I were speaking to somebody about a security data lake, maybe a cloud-driven security data lake by one of the big CSPs, I might have heard a similar description to what you just gave me. How is that different in the world of a fabric versus me
Yeah.
just pushing all data to some centralized data lake in the cloud?
Right, and that's a great point. And the overlap between the data lake and the data fabric is quite sort of tight. But the challenge with the data lake is it becomes a data swamp very quickly. And so, how does it become a data swamp? I mean, I think primarily it's around sort of the tragedy of the commons. I think people, without sort of the right type of governance or the right type of attention paid to the metadata, and to the schemas, you end up sort of with this sort of swampy type of data lake that doesn't really service the the organization. I mean, I think the essence of the data fabric is it kind of has the data lake, but with an element of governance, an element of sort of ownership around sort of the data pipelines and the data coming into it, right? So, the idea that you can just sort of dump everything to a data lake and everything will be rosy. I mean, who's relying on those data pipelines from these applications? Who's monitoring them to make sure they are delivering as they said they were going to deliver, and who's then going back to the owners of those applications if they aren't delivering the data? So you need sort of that element of governance and discipline around the data lake. And I think that's kind of where there is maybe a little bit of confusion in the market, but that to me seems to be the difference between a true data fabric strategy versus a data lake. Is just that element of like, the data fabric prevents it from becoming swampy.
So can I try out a word and see if this fits? So it sounds like almost a more curated approach to this collection of data. So it's not just sort of raw in its initial state. You mentioned several things in the conversation or the description you just had. One was common format. So one is you're gonna take all that data and convert it into some kind of a common schema. You're also going to make sure that the data is cleansed at some level, or that the data is valid. Is there a correlation element that's
Yeah. So
involved here too?
curation is actually a phenomenal word. That's a really good way of thinking about it, because to your point, it isn't just it it isn't just you can just dump anything in there, and it isn't, the curation piece is really important. And as the data kind of comes in, there is sort of a lot of work that's done on that data to kind of make it this single source of truth. So as it comes in, to your point, like it's normalized to a data schema. Potentially you're sort of enriching that data and sort of piecing things together. As an example, within a security environment, you might have a lot of different tools that are describing the same asset, right? And so how do you stitch all that sort of together into a single entity? And like, for example, for me, sort of in my workplace, I have a employee ID number, and I have an email address, and I have an NT login. And so I'm going to be interacting in different systems with some of these different sort of identifiers. But really, I'm me. And so how do I, when all that data is coming into the data fabric, how do I also sort of harmonize that and pull that together so there is a single entity that is me, and all the tools that speak in these different languages kind of are aligned to sort of my particular data source.
Great. So a couple other clarifying questions here, though, just to make sure that our listeners like get the whole picture. So the pipeline element itself, so the transport of data from source locations over into the data fabric, is that part of the data fabric process itself?
Yeah, it definitely is. It's an essential part of like how you get that data out, how you sort of, and as that data comes out on stream, how do you map that again to that common schema, and as well as when that data comes out, what are the transformations that you are doing on stream to that data, before it even sort of lands into the sort of data fabric, and so that's a key element of thinking about sort of the data fabric strategy.
Got it. Got it. Got it. And just one other point of clarity on the idea of curation. Often I think about curation as a human task, right? There are people that are curating my data. Is what you're describing a set of automated capabilities, or is there a human element, the sort of notion of curation that's required by people to manage the process?
I think it's sort of people set the automation. I think. I mean, I think there is you want to automate this as much as you humanly well. You want to automate this as much as you possibly can, because to your point about the sheer volumes of data, it's very hard to sort of humanly curate it. But there is going to be sort of an element of more in that oversight of making sure that you have telemetry and observability of the data coming in and those data pipelines, so you have data quality checks to look at things if they are sort of not flowing in the way they should be.
Got it. Got it. Got it. And some of the SIM vendors I talk to talk about similar capabilities that they have built into their SIM tools. Can you make any hard differentiation between the notion of what some of the more sophisticated SIM offerings put in place today versus a data fabric?
I think sort of the SIM offerings potentially sort of again, it's not the decoupling that we were thinking about, and so you're still maybe tied a little bit to the SIM vendor, the SIM's architecture, the sort of potential schemas that they might have, the compute that they have. It sort of, I think when you have that data fabric, you really do have that decoupling and that flexibility and approach that I think, again, while the SIM vendors, again, I think probably have a lot of solutions for a lot of customers. I think it's that flexibility maybe that you sort of trade off or lose, as well as again the proprietary schemas, and potentially you are sort of trapped into a schema that is somebody else's schema.
Got it. Got it. Got it. So this is a true separation of, in traditional SIM environments, this is basically a set of functions or capabilities that are built on top of the data layer in the SIM. So, every SIM does both of these things, right? It manages the data layer, all the aggregation, normalization of data, but it also then layers on a whole set of capabilities that sit on top of it around analytics and for many more formal threat investigation and response type capabilities. That's not what you're doing right here. You are focused on the data layer itself and providing a more agnostic, normalized, flexible data management layer to support then a series of capabilities, potentially a SIM, right, could certainly tap into the data fabric, and an XDR solution could tap into the data fabric, and lots more, correct?
Yeah, correct. And so it's not, sometimes there's we wouldn't want to necessarily pick a battle, meaning like there's a place for both of these things, and it's not necessarily a SIM replacement. It's the how do you make how do you make the things flowing into your SIM more effective and more more even cost effective, right? Like how do you make sure that you're almost doing some of that pre-work sort of earlier on in the pipeline versus relying on it all having to, or placing the burden all into the SIM and making sure that the SIM is doing all the analytics, all that sort of stuff. It's kind of trying to, again, tear that apart a little bit. And it doesn't necessarily replace the SIM. It definitely can help augment the SIM. And the same with the XDR, right? That becomes a set of inputs into the data fabric. But why sort of limit yourself to just the things that the XDR is pulling in, right? Like there's going to be additional context and additional things that you want to have the flexibility to bring in, such as HR data, right? Like it's very interesting to kind of understand, sort of what a sort of a laptop or an asset is doing. It's even more interesting to understand that sort of what that person's role in an organization is. Like the sales leader might be accessing certain things and that might not be a right, and an engineer might be accessing other systems and that might not be a right. But if the sales leader is suddenly sort of doing a bunch of command line sort of operations, like then you might be like, that's interesting, like we should probably investigate that a bit more. And so I think when you think about the inputs that are coming in, the security data fabric can really enable you to sort of like widen the aperture on the types of data sources you're bringing in and analyzing and sort of adding to this kind of rich data set.
Got it. Got it. Got it. So let's put a finer point on some of the challenges that this solves for people. So you just spoke of one of them, which is sort of breadth and flexibility of data types that can be now transported, managed, and made available to the security use case. You also have hinted to some storage costs or scalability type challenges that this architecture may also help people overcome. Could you be more succinct with sort of a set of like when you're talking to a security architect, like what are the key challenges that the fabric will help people overcome?
Yeah, again, SIM cost. I mean, I think a lot of people are looking at some of their SIM costs, and they keep sort of going up and up and up and up. And in some ways, from customers we've spoken to, sort of storing all your data in the SIM, especially the voluminous data, is probably the most expensive or one of the most expensive places to store all your data. And so, again, in that quest for full visibility, which I think is a quest that all security professionals are after. Um, Storing all your data in the SIM just becomes cost prohibitive, and you inevitably have to make more trade-offs. And so how do we move to a world in which you're making fewer trade-offs with your data? And so if you can find lower cost alternatives that maybe are presented by the security data fabric, why not use those? And then again, back to the idea of like, you still need the SIM and you still push things into the SIM, but it's now the higher fidelity alerts, the more sort of critical alerts that you've sort of pulled in, but you still have this vast corpus of data to do sort of more interesting sort of analysis on sort of more dormant threats or sort of more lower level types of threats and challenges. So I think that's one area.
What other key challenges we're overcoming with this strategy? You just talked about you can do more analysis on a sort of broader set of data that's here. Are we using other people's analytics capabilities, or are you providing analytics capabilities as part of the fabric?
You can use other people's analytics capabilities as part of the fabric. I think, for example, like Sigma rules is a good place to sort of start, right? Out of the box, sort of open source, sort of trying to move into that detections as code. Treat it as like a software development lifecycle is really interesting. Like I think that is a really interesting way to sort of evolve detections and become more like any other piece of software. And so I think that's definitely an interesting piece. The second piece I think we were talking about is not only the storage cost but the compute. And so if your storage and compute are tightly coupled, when you want to do more threats hunting or when you need sort of more horsepower, you're sort of reliant upon being in the queue with the SIM, versus if you have the data and compute decoupled, you can spin up the additional machines that you need as and when to kind of do more and more work, and then you can spin them down. You aren't constrained as much, and that's kind of again part of the benefit for decoupling storage and compute.
So let me clarify on data lake versus data fabric. Are we saying it's an either or question? It's either I choose a data lake strategy or I choose a data fabric strategy, or do these functions work together cooperatively?
Yeah, I mean, it's a great question. It's definitely not an either or. The security data fabric can almost act as that governance mechanism for the data lake to prevent the data lake from becoming the data swamp. And I think that's really kind of how we think about it. And so, and if you weren't to have a data fabric, a lot of the things you would want to do around your data lake to prevent it from becoming swampy would look very, very similar to like a data fabric, right? You would want to think about your schemas. You would want to have clear governance, clear ownership, and a lot of that stuff is stuff that you kind of get from implementing like a data fabric strategy. So definitely not a binary decision. We've had a lot of customers that will have a data lake, and we're almost like sort of the upstream cleansing engine that then gives them this kind of clean, pristine data into their data lake.
Okay, so let's just put a fine point on this because I want to make sure everybody understands. Do I need a data lake if I'm using a data fabric?
Thank you for clarifying. No, you don't need a data lake if you are using a data fabric. You can kind of use lower cost storage options. For example, we aligned like the iceberg formatting, and so you can use sort of cheaper storage options, and definitely don't need a data lake.
So regarding implementation, interesting, as you've been explaining all the functions that we have here, I'm thinking to myself, I've talked to large, more sophisticated companies that had engineering talent on board. They built these capabilities for themselves. And so is this a build versus buy question? Or does this bring a level of sophistication that the average organization just would not be able to accomplish on their own?
Yeah, I always think of the proverb, which is like, if you want to go sort of fast, run alone. If you want to go far, go together. And so I think it's all about having sort of key partners, because look, a lot of people can, like to your point, sort of large enterprises can sort of do the data pipelining and build sort of that upfront work, but it's kind of almost like thankless, sort of underappreciated work. Like nobody ever got a gold medal for making sure all their data was arriving. The places where security teams get to come alive and get to be sort of more invigorated is like with the higher level analysis. And so again, if you can partner with somebody that can kind of do that upfront cleansing, that upfront normalization, that has already done it, and that is also then tasked with having to sort of check those things, and when the underlying data sets change, they're already going to be aware of it and will make sure. Why not let them sort of do that sort of in the trenches work and sort of free your security teams up to do this kind of higher level analysis with this clean, pristine data? Again, yes, you could probably build it all yourself. In the same way, you can sort of probably manage all your servers yourself, right? But you sort of rely on the cloud, and sort of have a division of labor there. So I think that's kind of an interesting debate that every company needs to kind of have around sort of it's not build or buy. It's like, well, what bits do we want to buy and what bits do we want to build upon? Is the way I think about that.
All right, so let's paint a picture about future state. So explain to me what the cyber tech stack looks like when a data fabric is in use. So what is the major architecture look like going forward? And maybe while you're describing that, talk a little bit about how some of your customers go through the implementation journey to get from their current world as they go through this re-architecture, this transformation of the data layer.
So the future, I think this is going to be an unpopular opinion, but I think unfortunately we're seeing sort of before, I think cybersecurity sort of had unlimited budgets and they could always kind of go and ask more. And I think over time, sort of, while cybersecurity budget is still growing, I believe, with each successive cycle, like the budgets are going to sort of, be more and more restrained. And so I think that, the cybersecurity tech stack of the future is going to have to be very clear on the impacts that it delivers or the return on investment, which is going to be an interesting one. And so, I think that's the first interesting piece about sort of where I think that the future tech stack is going to look. And so I think the second thing is, like, I think we haven't really done a good job, and still today, on the basics, right? And so I think with the data fabric, it does kind of enable, you to sort of almost address some of the basics and the sort of security hygiene issues that have kind of plagued a lot of different security tech stacks. So just having things like sort of clear ownership, who owns your assets? Well, number one, where are all my assets and what are all my assets? And then the next question, who owns all my assets? And should they? And then I think that's enabled by the security data stack. Sorry, by the security data fabric. And so you first of all address like sort of the security hygiene issue, and then I think if you sort of look at the stats, like there's still too many tools. We've had a lot of tool sprawl. I think some of the tools have led to data sprawl. I think a security data fabric can enable you to rationalize some of those tools and ask the questions of, do I really need sort of all of these tools, or is actually some of these tools producing the thing or the protection or the coverage that I need? And it was only until you sort of had all the tools in a common language that you could even understand that. And then I think the additional thought is obviously the biggest problem in cybersecurity is too many alerts. And so by being able to kind of overlay more data together, we can really reduce that incidence of false positives. And so how do we cross-correlate and sort of smash together different data sets so we can really, really lower that false positive rate and make those alerts a lot clearer, to the analyst, thereby preventing analyst burnout. And then finally, we, anybody that really wants to unlock the promise of AI really does need to sort of pay attention to the data layer. It's obviously, such a cliche that garbage in equals garbage out. But, if you want to sort of accelerate that path to the AI, sort of having your data in a clean, normalized format really helps you there. And interestingly enough, I think not relying on the AI, horses for courses, right? Like if you are going to rely on the AI to not only clean up your data and then find the hidden correlations and find the hidden patterns, I think a lot of that journey is going to be a lot of disappointment because it's going to be very expensive to run the models and it's going to be more prone to hallucination. And so if you can kind of do a little bit of cleanup to begin with, right, and a little bit of like, automated sort of cleanup to kind of ease the cognitive burden on the AI, it's going to accelerate your AI journey because it's going to be cheaper because the AI isn't going to be having to do as much. And then secondly, it's going to be more effective because it's going to be less prone to hallucinate because it's not trying to do two tasks. It's just trying to do the one task. It's trying to look at your clean, normalized data and look for these kind of hidden patterns versus let me clean up the data first and then let me look for the hidden patterns.
That was a really important point. It's come now a bit late in our conversation, but one that I think everybody sort of can relate to, sort of the importance of the AI data pipeline. We are going to feed security data into models to be able to get the value out of the kind of AI capabilities that we're going to put in place. And we do need to think about that as a sort of early on in the conversation as we prepare to push more automation into the security operations process itself. Tell me about implementation. Can I spin up a data fabric in parallel to my existing environment? It's already in my critical infrastructure for my security function. Can I start by laying down the security fabric and start to gain value from it in small steps rather than a giant leap overnight?
Yeah, I mean, I think that would be the advice to anybody is to kind of start small and sort of grow from there. And so I think, step number one could be, do we have any voluminous data that again we're not currently even doing anything with because to put it into the SIM was just cost prohibitive? Can we do something interesting with that, and start feeding that through the data fabric?
So
Run
maybe,
some
sorry to interrupt. So maybe like some network, like a lot of people
exactly.
hesitate to pour a lot of network data in because it's so massive. Maybe some of my cloud data too, right?
Exactly. Start with some of these smaller, again, things that would be interesting for you to look at, but you just know you can't because you're just going to blow up your SIM bill. Can you put those first into this data fabric and look for sort of hidden things in that, and then you can even sort of create alerts that then get fed into the SIM. And so you want to start on the journey with a couple of clear use cases. Again, SIM cost reduction is a really good one. And I guess it's less about cost reduction and more like data trade-offs. And so again, if there's already like data, that you would like to look at, but you're not like putting that into the data fabric and then getting that in a more condensed form into the SIM seems like a very worthy sort of easy, well, not easy, an easy ROI sort of type of endeavor.
Got it. All right. We're going to try to wrap up here. And I'm going to ask you for a couple of simple words to describe the value of this thing. Things that come to mind after listening to everything that you shared with us today. Flexibility, scalability, and hygiene are three words that come to mind for me throughout the process. What would you use to describe maybe sort of key takeaways on value for this approach?
Yeah, I mean, flexibility. I mean, you stole my words. They're great. I mean, flexibility is definitely true. Scalability, I think, composability, right? As well as I'm not sure what the pithy term is, but the idea that you can just kind of widen the aperture of your data sets. So yeah, I don't, maybe visibility, I don't know. Like, but the idea is you're not just constrained to security data. You can sort of look sort of wider across the organization and incorporate more types of things in, to the fabric.
Awesome, awesome. Well, Robin, thanks so much for your time, for your insights, and I hope all of our listeners learned a little bit about what's possible with data fabric. Data B provides a solution for this data fabric conversation that we've had today. We haven't talked a lot about the specifics of data B itself, more general topics about data fabric. If someone wants to chat more with you or somebody else from data B, how do they go about doing that?
Yeah, I think just go to datab.ai, and we'd be happy to sort of walk them through. They can just kind of reach me there. I'd be happy to answer any questions or follow-ups that they might have.
Yeah, awesome. And somebody surprisingly let me know the other day that when they reached out to you guys, they actually got to speak directly to you, which was fun. So I urge everybody to look for more and engage in a conversation with Database. So thanks very much for your time today, Robin.
Thanks very much, Dave.